Hello and welcome. This is Obi Science Lab. Today we'll have a chemistry question to address. The question says 20 cm cube of carbon 2 oxide as part with 20 cm cube of oxygen. If all the volumes of the gases are measured at STP, calculate the volume of the residual gases after sparking. The question is asking us to calculate the volume of residual gases after the sparking of these two gases. And the two gases are carbon 2 oxide and oxygen. So let's first and foremost write the equation of the reaction, because this question is pointing at Gay-Lussac's law, which compared volume and mole ratio, saying that the mole ratio is directly proportional to the volumes of the gases involved in the reaction. So let's see the equation of the reaction. Carbon 2 oxide is CO, sparked with oxygen, O2, giving us carbon 4 oxide as a product. So we'll balance the equation. In balancing this equation, we'll put 2 here and put 2 here. We have 2 carbon, 2 carbon, 4 oxygen, 4 oxygen. The equation is balanced. These are gases. Of course, they are gases. So what's at the mole ratio? This is 2 moles, ratio 1 mole, ratio 2 moles. So these are the mole ratio, and we're going to use this mole ratio to compare the volumes involved in the reaction or in the sparking of the two gases. And before the sparking, what are the volumes involved? Carbon 2 oxide, 20 cm cube was involved before the sparking. White oxygen, also 20 cm cube was involved. 20 cm cube. This is before we have products, that is before the reaction. So after the reaction, what are we going to have after the reaction? We are going to have 20 cm cube of carbon 2 oxide. So this 20 cm cube of carbon 2 oxide can only take 10 cm cube from this 20 cm cube of oxygen available because of this mole ratio, 2 ratio 1, meaning 2 can only take 1 mole of oxygen, 2 mole of carbon 2 oxide and take 1 mole of oxygen in this particular reaction. So if carbon 2 oxide is 20, can we take, if oxygen is 20 cm cube and carbon 2 oxide is 20 cm cube, it can only take half of what oxygen is provided. So the volume of oxygen provided is 20 cm cube, so it can only take 10 cm cube, and we'll have 10 left unreacted, 10 cm cube. While the product side, we will have 20 cm cube. Why do we have 20 cm cube? Because of these 2 moles telling us that it will have 20 cm cube, because of these 2:1:2 mole ratios. In terms of volume, that volume will maintain that ratio of moles, which is 20 cm cube. This one was the half of it, 10 cm cube, and this one will be equal in volume as this is equal in terms of moles. So this is what we have, and the question is asking us calculate the volume of residual gases. So residual gases is equal to the unreacted gas plus the product. Unreacted gas plus your product. So the volume of the residual gas will be equal to the unreacted gas is this, and it's 10 cm cube, and plus product is 20 cm cube. So 10 plus 20 cm cube will give us 30 cm cube. So the volume of the residual gas is 30 cm cube, and that is our answer. So from the options now we have A is 40, B is 60, C is 30. C is the correct answer.